Alright guys, topic for today is special right triangles. We're going to skip a few pages in the notes having to do with these similar right triangles. If you want to learn more about them, they're going to be in the regular notes videos within the regular Unit 5 module. So we're going to skip down here and we're going to talk about special right triangles. We have two different types of special right triangles. We have our 45, 45, 90, which is going to be the first case that we cover here on this page, and the 30, 60, 90. So let's take a look at these first few examples and find our pattern using Pythagorean theorem. If I work through here on example number 1, here I'll give it a number, we have, let's see, I'm going to write it up here, 6 squared plus b squared is equal to, and remember from yesterday, make sure that you put all of this in parentheses, 6 square root 2 squared. So I've got 36 plus b squared is equal to, this is going to be 36 times 2, which is 72. So keep going, b squared is equal to 36, and b is equal to 6. So if we fill all of this in, I have 6, 6, and 6 square root 2 for the hypotenuse. Let's do one more. So on example number 2, I've got 7 squared plus 7 squared is equal to c squared. 49 and 49 gives me 98 is equal to c squared. And whenever I break this down, this is 49 times 2. 49 is 7 times 7. The 7's leave the house as 1, and the 2 stays. So my c squared is 7 square roots of 2, 7, and 7 for A and B. Now, without doing anything on example number 3, if we are given that our c squared, or rather our c, is 3 square root 2, if we look back at our pattern, what you'll notice that is that not only are these right triangles, but they are also isosceles with that 45 and 45. And if my hypotenuse has a length that has that root 2 attached to it, then A and B are whatever that coefficient is to that root 2. So this would be 3 and 3 and 3 root 2. Now, in our pattern for our 45, 45, 90, it is the square root of 2 times the leg is equal to the hypotenuse. So I'm going to draw this down here. We're going to have, I like to use A's, A, and A root 2. This is our pattern for our 45, 45, 90 right triangles. If we take a look at our 30, 60, 90 triangles, we're going to run through the same rotation here. So on example 1, I have 4 squared plus b squared is equal to 8 squared. That is 64 minus 16. So b squared is equal to 48, and I'm going to bring that over here since I'm running out of room. 48 is, let's see, 4 times 12, 4 times 3. I'm going to go ahead and stop there since I have a pair of 4s. It's just going to give me 2 pairs of 2s anyway. So my b is going to be 4 square root 3. My A is 4, and C is 8. Let's work example 2. So in this case, I'm looking for the short leg, A squared plus all of it, 6 root 3 squared is equal to 12 squared. So A squared plus, this will be 36 times 3. So our 108 is equal to 144, and if we do 144 minus 108, we end up with a squared equal to 36, and A is equal to 6. So I have A is 6, B is 6 square root 3, and C is 12. So you'll notice already that you're starting to develop a pattern. If I take a look at the third example and relate it back to 1 and 2, if I'm given 5 for A and 5 root 3 for B, then my C is going to be double that coefficient, 10. So for our 30, 60, 90 triangles, our short leg, which is our A, is going to be multiplied times the square root of 3 to get the long leg. And back to the short leg, if I have a short leg with a value of 5, my hypotenuse was 10, so it is 2 times the short leg. Now, whenever we draw this one out, I'm going to go ahead and label my 30 and 60. We always go back to the short leg. And remember that our shortest side is opposite our smallest angle. So if we run through our list here in reference to A, I'm going to have A here, and I'm going to have A square roots of 3, and my hypotenuse, which should be my long side, is going to be 2 times A. Now, if you get the 2 and the root 3 mixed up, just remember that your hypotenuse has to be the longest side. So if I take 2 times A, that's going to be greater than A times the square root of 3, because the square root of 3 is about 1.7-ish. Okay? Now, you guys know me. I like a lot of routine, and I like a lot of structure and procedure in my math, so I'm going to try to work you through these the best that I can. It's different because I can't ask you these things in class, but I'm going to try to lead you through these patterns and the easiest way to make them happen and make them work. So I'm actually going to skip past these first couple of pages. It might just be one page. No, it's 2. So I'm going to skip past these. I may go back and do another video with just these 2 pages if you feel like you need a little bit more help. But I really like these examples down here at the bottom. So down here under special right triangles, notice that all of these angles are labeled. And if they're not, we're given some sort of a clue, especially on these 45, 45, 90. If it's isosceles, then it's got to be a 45, 45, 90. If the angles are not marked, and if we are not given some sort of clue that possibly we have an isosceles triangle, don't ever assume things to be 30, 60, 90. We'll talk a little bit more about that whenever we get to trig, but don't ever make assumptions about these angle measures. Remember that for our rules, I've got a 45, 45, 90. I'm going to just go ahead and mark it here. And I have A and A and A square roots of 2. And for my 30, 60, 90, everything refers back to the short leg. Here is my 60 and my 30. So my 30, my short leg, is going to be A. My long leg will be A square root 3. And my hypotenuse will be 2A. I like to list these outside of every triangle just so that you'll get to learn the patterns. And we're also going to get exact answers with these, whereas whenever we move into trig, that may not be so. So here I have a 45, 45, 90. I'm going to go ahead and label all of these A, and A square root 2. So these 2 legs will be the same, And if my a is 6, then my hypotenuse will just be 6 square root 2. Here again, don't let this square root 2 throw you off. We still have our leg lengths of a, and a square root 2. So when I look at what I have written in orange, I can see that to get from the leg to the hypotenuse, I multiply by the square root of 2. So if I take my 9 square root 2 and I multiply it times root 2, when we're multiplying with radicals, insiders can mingle and outsiders can mingle. So if I do 9 times a 1, that's kind of invisible here, I end up with a 9. If I do square root of 2 times the square root of 2, you can either think of that as the square root of 4 or just as a 2. So this will be 18. You're going to have to learn how to really work with these radicals forwards and backwards, whether you're dividing by a square root or multiplying by 1. So here on number 3, I'm going to go ahead and label it as a, and my hypotenuse as a root 2. In this case, my 9 is the a, so these two are just 9 and 9. Let's look at number 5. Go ahead and erase those arrows. So here, I'm going to have a, and a square root 2. So my question here on this one is, how do I get from the hypotenuse back to the leg? And you can think of it as taking away the square root of 2, but really that operation is division. So we're going to have to work a little bit with that division. If I do 8 divided by the square root of 2, this down here is illegal. It's just something that can't happen in math. We've got to adjust it to make it acceptable. And what we do is we refer to it as rationalizing the denominator. Now, you've done this before. You have slept a lot since then. So remember that in order to remove something from a denominator or to change the appearance of any type of a fraction, we can multiply both the top and the bottom by the same number and end up with something that's equivalent. And in this case, if I want that square root of 2 gone, I'm going to multiply both numerator and denominator by that square root of 2. And remember that whenever we multiply fractions, we multiply straight across. So outsiders can mingle, insiders can mingle. 8 times the square root of 2 will just give us 8 root 2. And when I do the square root of 2 times the square root of 2, it busts out of the house as a 2. We are almost done. So if I take 8 square roots of 2 over 2, I can then work with these outsiders to simplify. So 8 divided by 2 is 4, and the square root of 2 stays. So this is 4 square root 2. If you need to, rewind that, watch it again, rewind it again, watch it again. There will be a pattern. We'll discuss it here in a little bit once we get to the end of these notes that will help you rationalize a little bit faster. All right, so let's look at our 30, 60, 90s. So our short leg that we always refer back to has a value of a. Our long leg is a square root 3, and our hypotenuse is 2a. So my question has always been, how do I get from the short leg to the long leg? And the answer to that is to multiply by the square root of 3. So if my short leg is 5 square root 3, and I multiply that by the square root of 3, outsiders can mingle, so the 5 stays. And when I multiply root 3 times root 3, it's just a 3. So my long leg has a value of 15. Now, if we want to look at our hypotenuse, I'm going to go back to the short leg. So I'm going to take my 5 square roots of 3, but this time I'm going to double it. In the same way that if I have 5x times 2 gives me 10x, this square root of 3 stays put. So 5 times 2 is 10, and the root 3 stays. Okay, I'm going to list out my pattern. My short leg is a, my long leg is a square roots 3, and my hypotenuse is 2a. So I'm given the hypotenuse, always work back to the short leg. If my hypotenuse is 8, then I divide it by 2 to end up with my short leg, so my x has a value of 4. And to go from the short leg to the long leg, I just attach that root 3 to it through multiplication. So this will be 4 square roots of 3. Let's go ahead and work this one as well. I have my a and a square roots 3 for the long leg and 2a. So we're back in that same boat that we were up here with our 8. In this case, if I'm taking out the root 2, I'm pulling it out of that whole number of an 8. And I do that through division. It's the same thing here with 18. So to get from the long leg to the short leg, I'm going to divide by the square root of 3. So if my long leg is 18, and I want to take the square root of 3 out of it, I can't leave it like that. So rather than trying to simplify it this way, I've got to rationalize the denominator by multiplying by a form of 1 that will help me get rid of that root 3 in the denominator. So in the top, I end up with 18 square roots of 3. And if I have root 3 times root 3, that 3 just leaves by itself. And once again, I can look at these outsiders here. 18 divided by 3 is 6. And I'm going to leave the square root of 3. So this is 6 square root 3. And then to get from my short leg to my hypotenuse, I'm going to double it. So if I do 2 times 6 square root 3, again, it's like if I do 2 times 6x is equal to 12x, then this has a result of 12 square roots of 3. Let's see here. There are just a few more for you to work there. Let's look down at these problems at the bottom. I have a trapezoid here. You can tell by the right-hand side that this is a square, so I'm going to go ahead and move those 6's around. And now, because I have this 60-degree angle, I can use my 30, 60, 90 rules to solve for A and B. The reason that this works well for us is if I just were to give you this information, here is B and 6, and I guess in this example it's an A, you wouldn't have enough information to solve for A and B, but that 60 is that clue. So I'm going to change my colors here. My short leg is A, my long leg is A square root 3, and my hypotenuse is 2a. So if we follow that pattern, my long leg is 6. And to get from the long leg down to the short leg, I'm going to divide by root 3. So I'm going to do 6 divided by the square root of 3. I need to rationalize that denominator times the square root of 3 and the square root of 3. So this will be 6 root 3 over 3. And now these two outsiders here can simplify down to 2 square roots 3 for my short leg. And I double that for root 3 to get my long leg. And the last couple here, here I've got a square. We'll learn in Unit 6 our qualities of different parallelograms, and we have a square here. Our diagonals are congruent and they meet at a right angle, so we have a square. What that means is that these 90s over here are being split into 45 and 45. So I'm going to take this triangle and I'm going to move it over here, and my C value will be there. So I'm going to have 24, and I'm going to solve for that missing link. So I've got my A, and A square root 2. And to work my way backwards from the hypotenuse down to the leg, I'm going to divide by the square root of 2. I've got to take it out as I write a 3. There we go. Okay, so one of the things that maybe we'll talk about one of our live sessions is how to simplify these a little bit easier. What you'll notice up here with this is whenever I had the 8 and I took out the square root of 2, my coefficient dropped to a 4 and I attached the root 2. So I divided by 2 and I multiplied by root 2 on the end. And whenever we're working with our 30, 60, 90s, if I'm dividing by a root 3, well, my 18 got divided by 3 to give me this 6, and I attached the root 3. So if we follow that same pattern here, then I'm going to divide by what's under the house. So 24 divided by 2 is 12, and I'm going to attach that 2, root 2 rather, to the end of it. And last one here, I've got a 30, 60, 90. So this one here will be 60, which leaves 45 for this and 45 for that one. If my long leg, which is my 2A, is there, then I have my A here and my A square root 3. Always work back to the short leg. So 16 divided by 2 will give me 8. And 8 times the square root of 3 will give me 8 root 3. I've got a 45, 45, 90. So this piece over here will also be 8. And if I follow my pattern again, for my 45, 45, 90, I have A, and A square root 2. So this piece over here ends up being 8 square root 2. And then just a couple more examples here. I wanted to do one more that looked like this. So I've got my trapezoid here. Normally this would not be enough information to find what we needed, but now that we know our 30, 60, 90 rules, we can. So I'm going to take and split this up here, just like we would if we were finding its area. And I'm going to bring this 5 root 3 here. And I'm going to go ahead and list out my pattern. So my short leg is A, My long leg is a root 3. So there's my a value, and this is 2a. So if my a has a value of 5, that goes here. And my 2a is going to be 10. So it doesn't look like it. Obviously, it's not drawn to scale. If this piece here has a length of 5, then that means from here to here also has a length of 5 because that 10 is the entire way across. So x would be equal to 5 and y would be equal to 10.